Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I will be presenting my conference paper entitled Future Direction of Microalgae Biodiesel in Indonesia. I'm Ibham Veza, and this conference paper was written by me, my professor, and my colleague. We are from two different universities, from UTM Johor Bahru and from Sampurna University, Jakarta, Indonesia. We begin first by explaining the introduction. With its strategic location on equator, where intense sunlight available throughout most of the year, Indonesia is the perfect place to grow microalgae. The country has approximately 27,700 hectares for microalgae to be grown, with annual potential production reaching almost 500,000 tons. Despite its potential, the development of microalgae has not attracted much interest in the country. Few review papers have been published regarding this issue, but they tend to focus on the cultivation method and strain development. The objective of this paper is this review article aims to address two major issues in the development of microalgae biodiesel in Indonesia. First is the recent progress of promising strain development and the effect of microalgae properties on engine performance, combustions, and emission characteristics. And in terms of the benefit microalgae for biodiesel, microalgae are karyotic photosynthetic microorganisms that can be cultivated very quickly. Due to their cellular structure, microalgae can live in severe environment. Not only do they live in aquatic but also in terrestrial conditions. Over 50,000 species exist in Earth ecosystem, yet only 60% of them have been researched. It can be used for renewable fuels such as biodiesel, methane, hydrogen, ethanol, and etc. Biodiesel made from algae has no sulfur content, thus it can decrease the emissions level of SOx, a major cause of acid rain. Another advantage of microalgae for biodiesel. Numerous studies have highlighted various advantages of using microalgae biodiesel. Compared to other alternative sources, microalgae do not require intensive care to be produced. They can grow easily by only using water that is unsuitable for human consumption. Using microalgae can also reduce the competition with agricultural crops for arable soil. This is due to their higher growth rates and productivity using far less land area compared to agricultural crops. Rapeseed or soybean, for instance, need land area up to 132 times more than microalgae for an oil content of just 30%. Indonesia is a tropical country with abundant sunlight, which makes it suitable for the development of microalgae. The country has also great microalgae diversity. However, despite its potential, microalgae have not yet gained significant interest in Indonesia. Like other countries, Indonesia still focused on the utilization of biodiesel from the first and second generation biodiesel, such as from sugarcane or from edible feedstock, such as shown later I will show in the table 1. This is because their infrastructure has been established because the first and second generation feedstock, the infrastructure for that type of biodiesel has been established, thus massive production can be realized and lower production costs can be achieved. Currently, Indonesia has a B20 mandate for biodiesel, with palm oil being the major feedstock, aiming to achieve B30 by 2020. This is already achieved, and then slowly the country want to increase the percentage of biodiesel. Now that even with the use of current biodiesel from palm oil, new alternative sources are required to diversify the energy sources, thus achieving energy security in the country. So for example, this is the comparison between each potential feedstock from each country. As we can see here, Malaysia and Indonesia are rich with palm oil. So the focus of research in Malaysia and Indonesia to find an alternative feedstock, the research and development is still lag behind because these two countries has a lot of opportunity in palm oil. And in terms of the promising species for microalgae, Since lipid production is influenced by the characteristic of algae strain and the cultivation approach, it's important to isolate microalgae as each strain has different behaviors where suitable cultivation method must be selected accordingly. Figure shows, later in the next slide, show recent development of microalgae strain both conducted by university and government agency. And in fact, the total saturated fatty acid of Spirulina plantaceus from Lampung is among the highest in the world. So one of the microalgae strains found in Lampung, in one of the provinces in Indonesia, has among the highest in the world, the total saturated fatty acid. As you can see here, lots of universities in Indonesia have investigated microalgae strains. For example, from the University of Indonesia, University Gadjah Mada, and from the government agency. And there are points to consider. As a nation with massive available land, abundant supply of water, and high average sunlight, Indonesia has a great potential to lead the development of microalgae in the world. However, most of studies were conducted on Java Islands only, particularly in Central Java. Given the massive area of Indonesia and lack of energy supply outside Java, the development of microalgae needs to be investigated thoroughly throughout the country. Moreover, since biodiesel can be used to generate electricity besides its applications in automotive sector, the development of microalgae biodiesel can help the country to fulfill its energy consumption in several isolated islands or regions. For the conclusion, a very important issue is the direct application of microalgae biodiesel in the existing modern internal combustion engines. However, no studies can be found examining comprehensively the effect of Indonesian microalgae biodiesel on engines performance, combustion, and emission characteristics. No studies can be found. So this has plenty of room where a lot of researchers can examine the type of microalgae strains, how it influences the engine performance, combustion, and emission characteristics. Therefore, it's difficult to measure the feasibility of microalgae biodiesel if it has not been tested on real engines. Huge research gaps are found in this area. With its massive potential and natural abundance, Indonesia can be the leading nation in microalgae research. Further studies should focus on how to cultivate microalgae with suitable technology through a cost-effective method. And since microalgae has numerous applications ranging from pharmacy, automotive to cosmetics, more interdisciplinary collaborations need to be established between research groups throughout the country, from the biotechnology departments, chemical engineering to automotive research groups. Also, partnerships between university, industry, and government agencies should also be established. I think that's it from me. Thank you very much.